Welcome to Brain Vision.
Hello everyone, this is the solution to problem 18 of chapter 24 of college physics. In this problem we're asked to find the maximum distance at which a signal can be observed in a radar system on top of a tower of a given height, and what is the distance to this point along the ground. So remember, there was another problem that we solved earlier where we calculated what the distance to the horizon was for some kind of elevation, like a tower. And so we did that using the tangent second theorem. And what that tells us is that this distance, d squared, is equal to h plus r squared times h. Sorry, h plus r times h. So this is what the tangent second theorem tells us. But this is this distance, right? This is this straight line distance from atop the tower to the horizon, not the distance to the point where this tangent crosses the circle along the ground. So how do we find this distance along the ground? Well, if you know this angle theta and it's given to you in radians, then you can just say that s is equal to r times theta. This is just a normal arc length formula for a circle. But then how do you find this angle? Well, because of this tangential nature of the line to the horizon, you know that the triangle of r plus h and r and d is going to be a right angle triangle, where you're going to have a right angle at the horizon distance position over here and between the radius coming from the center of the circle. So if you have that this is a right angle, so this is 90 degrees over here, then you can figure out what this angle theta is, because you know that the cosine of theta is going to be equal to the length of the triangle next to the angle, so r, over the hypotenuse, which is h plus r in this case. So we're going to have h over h plus r is equal to cosine theta. We can invert this relation to find that theta is equal to the arc cos of of r over h plus r. So this is the value for the angle theta. And now just putting this into this formula over here for the arc length, we find that s is equal to r times, let me just abbreviate r cos to a cos. And so this is just going to be r times a cos over r of r over r plus h. And so plugging in the values that you're given, 500 meters or equivalently half a kilometer for the height of the tower, and 6,371 kilometers for the radius of the Earth, you find that this is 79.8 kilometers. So this is the distance along the ground at which you can detect signals in a tower of height 500.